we have talked about uh, active break cycles in the monsoon, and it's literally an intrinsic time scale, sometimes more prominent than the diurnal cycle. Many land regions have a diurnal cycle in precipitation, but in over the Indian subcontinent for the summer monsoon, this active break period is very prominent, and we don't have a very clear theory for it. They are related to these northward propagating systems that come up mostly over the Bay of Bengal, some over the Arabian Sea, and then they seem to deposit some energy or terminate over the northern bay. And then you have these low pressure systems that propagate northwestward into the core monsoon zone, and there are ideas that they are involved in extreme rainfall events more recently, and so on and so forth. But essentially, people talk about vertical shear, horizontal shear as energy sources for the northward propagating systems or monsoon intra-seasonal oscillations, mesos, and then we have the active break cycles, where you have few days to few weeks of rainfall when you have more low pressure systems, and then you have a break period, which is also called a mini drought, when you have far fewer low pressure systems. So how all these are connected, what is the exact dynamics driving these, why they seem to be stuck in a corridor for a long time, and so on, are all important issues. So Krishnamurti here has been working on this topic for a long time, has very nice papers on the topic, and now he has come up with this paper on a new paradigm for active break cycle in the Indian summer monsoon. It's very hot. I forgot to turn on the fan, so let me do that. Give me 1 second. No, October heat, even though this is the end of October, October heat is a real thing here, and I don't run the AC, as I always remind you and remind myself not to run it. In this room there is no AC anyway. So anyway, what is the abstract? A multi-channel singular spectrum analysis, MSSA, of 121 years of daily rainfall over India and 43 years of outgoing long wave radiation and horizontal wind has revealed two dominant interseasonal oscillations that describe the space-time variability of the monsoon rainfall. We'll see lots of figures. The paper has lots of figures, lots of text, but I'm trying to keep it brief. Maybe it will still require 2 podcasts. Let's see. The two nonlinear oscillations are not perfectly periodic, but exhibit broad spectra centered around 45 and 28 days. These modes have coherent and near regular spatial structure and temporal variations. There are definitions that are involved in active period, break period, and so on, core monsoon zone, but then there are out of phase relations between the core monsoon zone and the northeast, the peninsular India and the core monsoon zone, and so on and so forth. So moisture supply issues, all kinds of issues exist. Remember, there is a background southwesterly wind, which also has an intra-seasonal time scale in it, etc., etc. Okay, these modes have coherent and near regular spatial structure and temporal variations. This study posits that the two nonlinear oscillations provide a consistent and comprehensive framework to study the variability and predictability of intraseasonal rainfall variations. Krishnamurti, since his PhD days at MIT with Ed Lorenz, has worked on predictability issues. The active and break cycles of the monsoon rainfall over India have been traditionally defined by using an arbitrarily chosen duration of persistence of arbitrarily chosen amount of rainfall averaged over an arbitrarily chosen area. So we looked at the data, we found some homogeneous regions, some time scales. So they were not spectrally chosen. That's kind of what you can think about in terms of time scales for defining these. These studies show that the phases of the two objectively derived modes of variability provide an objective method for defining the active and break cycle. That's the emphasis here, that they have found an objective way of doing this as opposed to the previous somewhat ad hoc subjective ways that we have done things. The two ISOs are further shown to make negligible contribution to the seasonal mean rainfall and its intra-annual variability. Here also there are some issues that Other people like Goswami have argued that the intraseasonal oscillations, the spatial patterns, look like intraannual variability, and thus seasonal totals are very closely related to the active break cycles, of course, but also intraannual variability is very closely related to these. But Krishnamurti has always argued that that's not the case, and he re-emphasizes here by saying the two ISOs are further shown to make negligible contribution to the seasonal mean rainfall and its intraannual variability. So there are many details. There is a season onset withdrawal, there is a seasonal total, and within that they have active break period. So what exactly do they do then if they are not adding up to contributing significantly to the seasonal total? And if year-to-year variability is not related to active break periods, then what is determining? So determining the intraannual variability. So it looks like there is some other process going on within which active break periods are acting. Okay. This study proposes that the investigations of the origins of these nonlinear modes and modulations of their amplitudes and phases provide a new paradigm for future research on validation and predictability of intraseasonal variations in climate models. So these, honest enough to admit that these require further validation, and predictability of course will always matter, because for farmers and water resource management and energy, everything else, active break periods are very critical in terms of predictions as well, right? The Indians, so I will read a bunch of text since we will probably do 2 podcasts. I won't be too lazy about reading the important text, and I'll still skip a lot, by the way, so you should read the paper if you are interested in this topic. The Indian summer monsoon, occurring mainly during June to September, exhibits considerable variability at both intraseasonal and intraannual time scales. The variability of the monsoon within a season is characterized by alternate active period of above normal rainfall with respect to the long-term mean, and break periods with below normal or no rainfall, and not everywhere but in some regions. A study by Ramamurthy in 1969 indicated that the monsoon trough brings high rainfall over central India during the active periods, whereas the break periods set in when the monsoon trough moves north to the foothills of the Himalayas. The break period was also suggested to occur when mid-latitude disturbances travel eastward. The active and break periods correspond respectively to the strengthening and weakening of the mean monsoon circulation, which is the southwesterlies that I mentioned. The convective activity in the equatorial Indian Ocean illustrates the active phase which propagates northward that I mentioned before, as well as eastward, and ends up at the foothills of the Himalayas. The break phase follows similarly, but with a suppressed convection zone propagating northeastward from the Indian Ocean, just eastward versus northeastward. Okay, so there are boreal summer intraseasonal oscillations, and there are northward propagations. There are a lot of questions about what makes the northward propagation happen, and so on and so forth. Generally, there are 2 to 3 active break cycles, each in the range of 15 to 60 days. During the summer season, the active break cycles consist of well-defined nonlinear intraseasonal oscillations with different periods. 2 leading ISOs with broadband spectra centered around 45 to 30 days were found in the multi-channel singular spectrum analysis, or MSSA, of rainfall, convection, circulation, and diabatic heating. Diabatic, not diabetic. Apart from the ISOs, there are seasonally persisting modes that do not vary much during the season but exhibit strong year-to-year variability. So you see where the active break periods are contributing or not contributing to seasonal totals and intraannual variability, because there is a standing mode which is doing some work as well. 2 such modes were found to be related to El Nino Southern Oscillation and Indian Ocean Dipole, again one of Krishnamurthy's previous papers. The finding of ENSO and IOD modes confirmed the hypothesis by Chani and Shukla back in 1981 that the seasonal mean monsoon rainfall is mainly determined by the slowly varying components such as sea surface temperature, soil moisture, and snow cover. So there is the important message there in the Chani Shukla paper, which basically says weather prediction may go chaotic after a few days because of the nonlinear system. So we treat it as an initial value problem. So sea surface temperatures are generally prescribed, and then the atmosphere is interacting with the land. But when you go to a longer period, there is still predictability. It's called predictability of the second kind, because now slowly varying sea surface temperatures make the coupled system a boundary value problem, and then you get predictability that actually went chaotic in a few days when you did weather predictions. Okay, in any particular year, the seasonal mean rainfall is mostly accounted for by the relative contributions of ENSO and IOD modes, while the contribution from the ISOs is not significant. I'm sure there will be papers coming on this further, maybe by B. Goswami and so on. Also, there are lots of controversies about whether the IOD contributes to the monsoon or the monsoon affects ENSO and IOD themselves, because IOD typically peaks during September, October, November, and it happens over a tiny place over the Indian Ocean, whereas ENSO is a monster. They are not independent of each other, and none of them are really independent of each other. A different viewpoint about what determines the seasonal mean rainfall has been pursued by some previous studies. Of course, Goswami comes in. In this scenario, the seasonal mean is supposedly explained by the frequency and intensity of the active break phases during any year. This hypothesis expanded on a suggestion by Palmer in 1994 using the three-variable Lorentz model that was not representative of the monsoon. So there are some justifications as to why this claim that ISOs don't contribute to seasonal mean is correct. According to this suggestion, the daily variability of rainfall should show bimodal distribution depending on the frequency of active and break phases. There are some technical details there that I won't go into. It's quite likely that this model combines the ISOs and the seasonally persisting modes to define the active and break phases, thus resulting in bimodality. However, the studies with this viewpoint have not proved strong evidence to show that that distribution of the active break phases determines the seasonal mean rainfall. Okay, so I'll jump ahead, and there is a lot of details on the data, the methodology, and other definitions, the issues of actually choosing active break period, time scales, regions, etc. What is the new definition? Composites of active and break phases are now examined to arrive at a suitable definition of active break cycle using the definition of the India Meteorology Department catalog, India Meteorological Department catalog, which was discussed earlier. So I skipped some text where this was discussed. The active and break composites of the total rainfall anomalies for the period JJAS 1901 to 2021 were constructed for IMD rainfall as shown in figure 9A and 9B. So I have jumped quite a few figures, but I will show all the figures. Similar active and break composites of the total rainfall anomalies were also constructed when the AIMR index of ISO 12 is beyond a threshold of plus minus 1 standard deviation as plotted in 9C and 9D respectively. Sorry about jumping ahead, but basically some previous paradigm figures are shown for these two modes, and then we shift into the new paradigm and explain that. When we go through the figures, it will become clearer. I put this ahead because there was some space here before we go to the figures here. Okay, so I'll come back and do that. A little bit backward, but either you are an expert and you know what is happening, or you listen patiently, and then you will understand if you are not an expert. Just get the main points, okay, if you are not an expert, because you may be doing water resources, hydrology, vegetation, other things, but you need to understand these things to the extent that we have a long-running paradigm for active break cycle, and now these guys are proposing something new, and we have to see how new it is and whether it needs validation, as we said, right? There are noteworthy differences in the composites based on the IMD catalog and those based on the ISOs, as they do it here. In the IMD composites that we will look at, the stronger anomalies are confined to the eastern part of central India, while the northeastern and southeastern regions have weak anomalies. So IMD produces eastern central India, whereas the ISOs look at northeastern and southeastern regions as well. Further, the break composite is weaker than the active composite over central India. The ISO 12 composites will look at show stronger anomalies extending from the west coast to the east coast, covering central India and along the western Ghats, which is orographic rainfall as well. The northernmost and northeastern regions show moderate anomalies of opposite sign. So it's split differently in space. The magnitudes of the active and break composites are comparable to each other. However, the ISO 12 composites, ISO 12 composites may exclude certain active and break periods where the AMR index may fall below the threshold of 1 standard deviation. So there are many ideas here and many details. We do AIMR, which is averaged over all India, and we do long-term average, and then we look at days above that or below that to then talk about active break periods. But now there is a new paper arguing that AIMR itself is flawed because it mixes the northeast region, which is completely out of phase with the central region. So also keep that in mind. Similar active break period active break composites based on the CIMR index of 12, ISO 12, so central Indian monsoon rainfall, as shown in supplementary figures that we will not look at, have close resemblance with the composites based on the all India monsoon rainfall index. So you are choosing different regions to argue different points or argue for differences. This study proposes an objective method, this is a key claim, objective method to define the active and break periods based on the phases of the AIMR index of ISO 12. The phases of AIMR index of ISO 12 is determined in the same way as the phase of PC1 of the RCs was determined earlier, so you can look at older papers. So there are spatial patterns and there are time series associated with them, so principal components and so on. The active period is defined to occur and the phase of the AIMR index of ISO 12 is between pi over 4 and 3 pi over 4, and the break period is defined as the period when the phase is between 5 pi over 4 and 7 pi over 4. That is the statistics of what MSSA gives you. Using these new definitions, the phase dependent active and break composites of the total rainfall anomalies were constructed for the period JJAS over 1901 to 2021, as we will see. Similar composites based on CIMR index of ISO 12 also revealed the same structure of the active break periods. These composites closely resemble those based on the standard deviation of the AIMR index and capture the structures of the active and break phases with the only difference in the magnitude. Okay, so there are some more details. Let's just jump to some figures. So the figure 1 is showing MSSA of daily rainfall from IMD anomalies over the land region of India for the period of JJAS 1901 to 2021. A is the power spectra of the first 6 eigenmodes, with light blue as mode 1 and purple as mode 2 and red as mode 3. Mode 4 is yellow, mode 5 is green, mode 6 is greenish yellow, and pairs 1, 2 and 5, 6 have almost indistinguishable spectra within the respective pair because of near degeneracy. Statistical terminology, so you have to really be careful. Explained variance becomes a problem as you go to higher and higher modes. The EOF1 of ISO 1 RC modes 1 and 2, and EOF1 of ISO 2 RC modes 5 and 6, and standardized PC1s of the RCs of the ISO 1 and ISO 2. So lots of information, but just look at how the mode 1 is in this bluish color, mode 2 is in this purplish color, they are almost going together. Mode 3 and 4 have this kind of exponential structure when you look at periods in days and the power in the spectrum, and you have mode 5 and 6 which are on a lower frequency, so higher frequency, so you have periods going from low frequency to higher frequency here. So you have the 25 days to 45 days that we mentioned before. So if you do these with IMD rainfall ISO 1 as EOF1, this is what you get, and IMD rainfall ISO 2 with EOF1. you get this wire. Okay, so same thing but different amplitudes, right? So this is much stronger here versus this one, and remember that you have basically yeah, B and C, and then we will look at rainfall ISO 1, ISO 2 PCs here. So ISO 1 is shown in this blue, which has a lower frequency. When you look at the season, this is for a particular year, and this is the standard deviation of IMD rainfall ISO 1 and ISO 2 PC1. So ISO 2 has a higher frequency, but you can see by the end of the year it is lower in amplitude, whereas this one has different peaks with lower amplitude in June but peaks in July, August, changing signs. But remember, you have to remember the spatial pattern and the PCs have to go together. Okay, so too much statistics for you, then don't worry about it. And second figure here is looking at EOF1 of RCs of ISO 1 and ISO 2 from MSSA of daily rainfall trim anomalies for the period, again 1998 to 2019, because that's all the trim data you have, which is a different product, and in many ways I don't know, you have to come, there are arguments made as to why you need to use one or the other rainfall product, because they can all differ at some level. Rainfall is tricky not only for modeling but also for measurements. So EOF1 of RCs of ISO 1 and ISO 2 from MSSA of daily OLR anomalies, also a different period, 1979 to 2021, but you get the idea that you have EOF1, ISO 1, ISO 2 and OLR ISO 1 and ISO 2. Obviously, when you have high rainfall, you have low OLR. Remember, cloud top temperatures colder, or OLR lower. So you have clearly this equatorial Indian Ocean or tropical Indian Ocean and the monsoon region out of phase relations, both in OLR and rainfall. ISO 2 is similar tropics, extratropics, but much weaker in amplitude, and similarly in OLR. But remember, we were talking about eastward propagation and northeastward propagation in these two as well. Okay, so if you can track all those, good, otherwise don't worry. So this is the 850 HPA wind, and this is ISO 1 and ISO 2. Their argument here is going to depend on ISO 1 and ISO 2, and that it is objective because it has two distinct time scales which are used to distinguish these objectively selected active and break cycles. Okay, so you can see that this is like a break cycle, this is like an active cycle. So you have more rainfall but also capturing Western Ghats, as they say, less rainfall, but you have different patterns compared to how IMD does it. And the circulation associated with that, there is a anticyclone here and a cyclone there, whereas the ISO 2 has anticyclonish circulation. Okay, so this is trim rainfall ISO 1, ISO 2, just arguing that if you look at different years, 2008, various things looked at in terms of rainfall, OLR and 850 hectopascal winds. Different years here. This is figure 3 looking at standardized PC1 of RCs of ISO 1 and ISO 2, and this is looking at AIMR index of ISO 1 and ISO 2 plus ISO 1 plus 2 RC. So these are essentially regressions. Lots of statistical analysis is done to argue for the new paradigm, which we will read in the summary to become more clear. I'm just plowing through the figures because it shows you how many details there are, and if you want to follow up, you can follow up. So the reconstruction of the total rainfall from ISO 1 and ISO 1, 2, so that's how it's done here. does well for many years, 1923, 55, 72 and 2004. That's where you want to come back with the ENSO and IOD contributions to interannual variability versus ISO contributions to the seasonal amounts and so on and so forth. So this is phase composites of total anomalies of precipitation for 4 phase intervals of the first half of the cycle of ISO 1 and ISO 2 for the period JJS 1901-2021, the total period because it's only rainfall based. The phase number is given at the top right corner of each panel, so you can see ISO 1 and ISO 2. So you can see phase 1, 2 of ISO 1. You can see you're starting here, amplifying, and then shifting. So this is argued to capture more of the spatial variability instead of just focusing on the core monsoon zone, which is the IMD definition of active break periods. Okay, ISO 2 captures the weaker aspects of the same thing, so you can imagine active and break periods, and the northward shift there is there in the phase 4 as well in ISO 2. So that's the basic argument. If you look at the phase composites of total anomalies of precipitation for 4 phase intervals of the first half cycle of ISO 1 and ISO 2 for the trim period, and the idea here is to look at the larger scale context. We often focus only here, northward propagation, low pressure systems, core monsoon zone and so on, but if you want to talk about eastward propagation, northeastward propagation and so on, you need to have a larger context. That monsoon is happening in a larger context, and that's how you get impacts of, let's say, ENSO and IOD, and in fact there are good papers also showing that the Atlantic Nino also affects these things. Okay, again I'm being quite brief about the figures because they are just adding more and more details. This is figure 8. I will stop after this figure because we are getting long. Again, re-emphasizing what we saw before. This is phase composites of total anomalies of 850 hectopascal as opposed to ISO 1, ISO 2. So this is from era 5 for 4 phase intervals of the first half cycle of ISO 1 and ISO 2. So you took total anomalies but project them onto ISO phases of 1 and 2. Okay, just tells you that there is a larger scale dynamics involved. So you are now focusing not only on this, but you did like you did before here. Okay, we also looked at these, but we didn't mention so much. So you have to, in your own mind, keep looking at the relation between tropical Indian Ocean and the subcontinental India, and what is coming from here as well, right? So again, if you're an expert, you are going to read this paper. If not, you are going to just try to take the main points. So here is now coming back to composites of total precipitation anomalies for JJS on the IMD active period and IMD break period. Okay, so active break very clearly defined based on this region, based on such figures. And if you do it with the ISO construct, the argument is that this is the ISO AMR active and AMR break as opposed to just phase, ISO active phase, ISO break phase. So this is done for phases 2 and 3 of ISO 1 plus ISO 2 AIMR. So this is based on total AIMR anomalies. This is done based on the splitting that they do here, and they argue that this spectral timescale split is much better. Okay, that's the main message. So I'll stop here because I am already 28 minutes, and please look at the figures more carefully, and if you want, follow up because these are important. But because so much statistical analysis is involved, because they are basically trying to prove the subtle differences between what IMD does in terms of its active break cycles and what they are doing and what new paradigm they are proposing. So in words it will become clearer when we read the summary. The main point is that they are saying the way they do it, there is separate seasonal and interannual variability that is not directly dominated or significantly affected by the active break cycles as they define it here. So these are all the statistical details on trying to do that. So in IMD break period and active period are shown here. In C and D we are showing ISO 1 plus ISO 2 AMR active period. So they are taking their statistical modes and projecting them onto the active and break periods of IMD, and then they are doing phases 2 and 3 of ISO 1 plus ISO 2. So that's the active break of the ISO 1 plus ISO 2 on AMR active period, and this is ISO 1 plus ISO 2 phases 2 and 3 of the AMR, and phases 6 and 7 of the ISO plus ISO 1 plus ISO 2. They are insisting on doing it this way because if you have a propagating mode, you have phases, and IMD is not talking about propagation in these definitions. These guys are trying to bring in the spectral analysis and the propagation aspects to define the new paradigm. So just remember those in words so that even if you don't understand the statistical details, you get the main message. Okay. Obviously these have to be accepted by modelers for prediction. Predictability has to be shown. If this approach provides better predictability, better predictions, then obviously people will jump on these. And remember that the model does everything. It's not trying to do ISO 1, ISO 2. It's just doing the total dynamics. And then when you do predictions, you do post-processing to look for these things. Or you can do model diagnosis to understand whether the model is doing the standing mode better than the propagating modes, or if it's doing both of them wrong. If so, why? They are doing both of them well. How are they related? How are they related to ENSO and IOD? All kinds of questions will have to be answered after this basic diagnostic approach to propose a new paradigm. So we'll come back and hopefully conclude in the next podcast. Okay.